let's say we are a travel agency and we have a data set with only two columns, okay? The trip ID and the city ID. So here the customers go on a multi-city trips, okay? For example, for the first trip, this one, so the customer has started from here, they went here, and then here, and then here, and the trip has ended. So we assume they went back to their original city, okay? And for the second trip, which is this one, so the customer has started from here, they went here, 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 and finally they went back to their original city, okay? So that's all the information we have. Now we have a new customer. Let's say they want to book a ticket to this city. Now, can we make some recommendations to them where to go next? Okay. It looks like from this data set, we have very little information because we don't know what these cities are, where they are, what is the distance between the cities. We know nothing, right? All we know is the trip IDs and the city IDs. So it looks like we cannot really make good recommendations where to go next, right? But there is an interesting way to solve this problem, and it's using this transition probability matrix. Okay, so let's see how to do that. Now, the same thing, let's say we have some 3 trips. Let's start with a Thai example. So here we have trip 1 where the customer started from city A, they go to city C, and then went back to their home city A. And then for trip 2, we have another customer. They started from B, went to A, went to C, and then went back to A, and finally went to their home B. And we have another trip. So what we do is, first we build these pairs, this from and to city pairs. Okay. So from here, the customer went from A to C. Okay. So from A to C, we have a count of 1. And then we ignore this C to A because the customer eventually go back to their home city, right? So we ignore if the end city is the same as the starting city. And then from trip 2, we have B to A, we have A to C, and then we have C to A, right? And finally A to B, which again we'll ignore. And finally from trip 3, we have A to B and B to C. Okay, C to A we ignore even though it's not explicitly stated here. So once we find out these pairs, then what we do is we build this transition matrix, okay, which is simply, so here we have all the cities on this, let's x-axis and y-axis, and we are going to fill this matrix. So all the diagonal elements will be zeros, and then we will count from the historical data how many times the customers traveled from city A to city B. Okay, so A to B, it happened only once. So here we have 1. And then from city A to city C, A to C, so here we have a count 1, and A to C, here we have 1 more. So we have a count of 2. Okay, so like that we fill all these elements. Now notice that this matrix, it need not be symmetrical, right? For example, maybe it is not necessary if there are 5 trips from A to B, it's not necessary to have the same 5 trips from B to A, right? So this matrix is not symmetric. And then here we have the total. So from origin A, how many trips happened? So here we have 3 trips, which is basically the sum of these, each row. Okay. So we have the transition matrix, and then we make it into probability. So we simply divide each row with this total value. So this diagonal still remains 0, and this become 1 over 3, this become 2 over 3. And then the second row, it becomes 1 over 2, 0, 1 over 2. And since for third row, we have only 1 trip, So it is still 100. That's our transition probability matrix. Now, let's say we have a new customer. Let's say wherever they start, let's say they started from D, they went to E, and then they are booking a flight to A. Now we can make some suggestions to customer A. Hey, do you want to go to city C? From this matrix, there is 2/3 probability or 66% probability that the customers who go to city A are likely to go to city C. Okay. And then there is the remaining 33% probability that they'll go to B. Now, it looks like it is too simplistic because we have only 3 cities here. But imagine when we have these multiple cities, and from a given city, we might have 100 target cities. But using this probability, we can make good recommendations where the customer is likely to go next. Now, in an indirect way, this probability also serve sort of the distance between those cities, with the assumption that the customers go choose the next nearest city as their destination. Okay, so here we have done using, let's say, pen and paper type of thing. And now let's see how we can implement this using programmatically. So here I'm just grouping by. So we are starting with just these 2 columns, just this data set, right? Which has the trip ID and city ID. Now, what I'm doing here is, so grouping by the trip ID, and then we are making it the lists or the cities in the trip as a list. Okay, so basically we are converting this tall data frame into a data frame where each row is a trip ID and each list is the list of cities they've been through, right? So first customer, they went from here to here, here to here, here to here, and finally went back home, even though that's not stated explicitly. Whereas this customer, here to here, here to here, here, and finally they went back home. All right. So step number 1, this is done. And in step number 2, we have to make all these pairs, this from and to pairs, right? So here we have initialized an empty list and we are going over all the trips. Okay. And we are checking if the first city is the same as the last city. In that case, for example, in this case, we want to ignore this final element, right? Because we are making an assumption, everyone will go back to their home city eventually. So we ignore from here, but from here, we don't ignore. All right. So here we are removing that last element. And then we are simply, so for example, let's take this one, right? So here from city, we are taking this as it is. And for to city, we are simply shifting the elements by 1. So we are making another array with these 3 elements so that we can build these from to pairs more efficiently, right? So here we are taking, this is the from city, this is the to city, and here we are making this list. Okay. And this will be a list of lists. And finally, we are making it a flat list. So the output from here, which is this from to, it looks like this. So it is a list of lists. We are printing only the first 3 elements. So the first element, as you can see from here, so we have a trip, origin, destination. Okay. So that's what we have here, origin, destination. And then here we have, then this becomes the origin and this is the destination. So the origin, destination, and finally from this trip, we have this as the origin and this as the destination. Okay. So that's what we built. So basically in this code from this given lists, we went over all the lists one by one and we built pairs of from and to cities. Okay. All right. So we have started with this tall data frame and we have converted into this list type of thing. And then we have computed these from to city pairs. And then we are going to build this transition matrix. Now, this code, there is a lot of vector thing going on here, but all we are doing is we are counting how many times each pair has happened, and we are counting, turning that into this transition matrix. Okay, it's not probability yet. And then here we are dividing with the total number of trips with that city as the origin. Okay, like this like the total here, right? So then it becomes this transition probability matrix. So here we have a transition probability matrix, and in this case we have over 37,000 cities in this data set. Okay, so this data set, it contains 37,000 cities. Now, as you can see, this is not a square matrix. That's because not from every city we might not have a probability to every other city, right? All right, and then we are writing a helper function here, which takes two elements as an input. So it takes the current city ID and how many cities we want to recommend for the next trip. Okay, now all we are doing is we are simply taking this transition probability matrix like this, and for a given city we are filtering for that city, and then this row we are sorting the row and we are returning the top n elements. Okay, so that's all we are doing here in this piece of code. But if anything is not clear, let me know in the comments. I'll explain the code. All right, so this is how it looks like. So we call a function. Now we have a new customer. They came to us to book a flight to this city. Okay, this is the city ID. And we want to make some recommendations to them. Let's say we want to make some 5 recommendations. So from the transition probability, these are the 5 cities we are most likely to visit, right? From over 37,000 cities, we are narrowing it down to just 5 cities. And here we have their probabilities. Okay, so some of these probabilities, for example, the probability for these 2 cities is really small, but the customer who visited this city is very likely to visit this city and these cities. Okay, all right, we have many cities with extremely low probability. So that's why if you sum the probability of the first 3, so it's 0.22, 0.160, so this is 0.4, it's about 0.65. So the remaining 0.35, it spanned over many cities, each with a very tiny probability. Okay, all right, obviously we can, this is a parameter. So if a customer is booking a trip to this city, we want to make only one recommendation. This would be the city with probability around 10%. Now this helper function, we can even take a minimum probability as a parameter, and we can recommend cities only with at least that probability. Okay. Yeah, so this transition probability, it has applications in many areas. Yeah. Right. I hope that's an interesting exercise for you. To me also, when I first looked at this problem, it looks like it's almost impossible to make some recommendations because all we have these city IDs. We don't know anything about those cities, where they are, the city names, or the distance between different cities, etc. But even from these simple IDs, we can make this transition probability matrix, and we can make recommendations. Now with each new trip, we will update the transition this probability matrix. So this serves as a simple lookup table. We don't even have to make any predictions. We can simply call this function to make the recommendations. But we have to keep updating this matrix. Okay, that's all for this video. Thank you very much.